So question on number 12 from the 11.2, 11.3 parabola worksheet. Right, here's the original problem. Find the equation of a parabola with the directrix of y equals 2/3 x minus 4, and the vertex was at 3, -1. Okay? Alright, so that's our given information for ourselves. Okay. So here's what I thought of. Okay, so this is definitely going to be a rotated conic, right? And how do I know that? Because if I graph it, right, there's my y-intercept. It's going to rise 2, run 3. So there's my directrix, my focus 3, -1 right here. So it looks like it's going to be something like this, going in this direction here. Okay, for myself. So what do I need to keep in mind? Well, since it's rotated, I need to find where the focus is. Okay, and once I find where the focus is, then I'm going to figure out using my distance equations, my two different distance equations. I'll set the distance is equal, like the distance from here to a point on it. Right? I'll make this distance from the focus to the point equal to the distance from the point to the directrix, and that will give me my equations. So that's my plan here for this one. Okay, so if you weren't sure how to get started with it at all, right, maybe hit pause, try that plan, and then you check back in. Okay, so let's find, in order to find where this point is, I'm going to need a couple things. First of all, I need to know remember that this is on the axis of symmetry, which is perpendicular to this line, so that perpendicular slope is going to be -3/2. So that's the slope of that line. We know a point that's on it. We know that that's a point on there, and so okay, we just need to figure out where that's gonna be, right, for ourselves. And so yeah, let's try to figure that out here. Okay, maybe I won't need that equation. How about I figure out where this intersection point is right here, right? Okay, and so to figure out that intersection point, that's where this line intersects this line, so I'll plug this in here. So I'll have 2/3 x minus 4 plus 1 equals -3/2 x plus 9/2. Okay, I'm gonna scale everything by 6 here, right? Because I just have so many fractions. See, this is -3, and then this goes -18. Right? This is going to be -9x. It's going to be plus 27. So I'm going to get 13x, and that's going to give me 45. So x equals 45/13. So that's the x value of that intersection. Okay, now we find the y value of the intersection. We can, it doesn't matter which equation we use. So I'm going to use this one right here. Right. So that's 30/13. This right here, how many 13ths is that? It's 52/13. So it's -22/13. Okay. Okay, and that's that point right there. Okay, so we also know where this point is right here. This is at 3, -1. Okay, for ourselves, and so remember that this is the midpoint between the focus and the to make these distances equal, this is the midpoint. So I could say 45/13 plus whatever this x coordinate is divided by 2 must equal 3. And then it'll give me the x value. And then I could do the same thing for the y value, -22/13 plus whatever this y value is going to be here. Right? Let me call it x of the focus and y of the focus. Okay, that's going to equal -1. Okay, and so when I try to solve that in terms of 13ths, that's 78/13. So x of the focus is going to be 33/13 for myself, and the y of the focus is going to be, that's 26/13. So I add that. So okay, so now I have my focus. My focus is that value right there, okay, for myself. All right. Okay, so now that we've just gotten our focus here, now let's go and figure out for ourselves. Remember that the focus is equidistant from the point that's on the graph and the directrix. So I'm going to write my two equations. Right? So I'm going to take this equation here and change it into general form. So I'll scale by 3. Okay, and then I'm going to move this over. Okay, then I'm going to go plug it in, right? And so I go down here, and the point was x comma y, so I plug it into that equation. And so this is my distance from the point to, this is from the point to the line. Okay. Now I'm going to set that equal to the distance from the point to the focus, right? So there's that second part of the equation. Okay. Now this distributed out gives you that not so nice pretty number. Just move it so the screen's better a little bit there. Okay, ignore what's below it. All right, I'm actually re-recording this video, so okay, because I made a careless mistake. All right, so this all distributes out right there. For this one here, when we distribute it out, we get, right, we just basically get the FOIL, so we'll get 4x squared minus 6xy minus 24x. Okay. And then we're going to distribute again, so this is going to give me negative 6xy again, good, right, plus 9y squared minus 36y, I'm sorry, plus 36y, okay. Then we're going to distribute negative 24, oh, we already had negative 24, so let's make that negative 48x minus another 30, I'm sorry, plus another 36, so that becomes 72y. And then negative 12 times negative 12 is going to give us 144. Again, I'm re-recording this video because I made a careless mistake right last time. Okay, so that's why you're seeing other numbers there. So we're at this point. Okay, now I'm going to scale everything by 13. Right, so this side's going to be 4x squared minus 12xy minus 48x plus 9y squared plus 72y plus 144. Okay, the other side's going to be this right here. Ignore the cross-out marks. That was my next step. Okay, for myself. Okay, and then I combine like terms. So I combine the x squareds together, right, and I brought that over. I brought it all to the right because that had a larger x squared, and I was going to use that as my leading term. So I brought that over. Then I brought the 9y squared over, so I had 9y squared combined with 13y squared to give me this. Okay. Then I brought the xy term over, right? The xy term came over. Okay, and I'm crossing out each one as I do it. That's why you see the crossouts. Okay. Now the x term, so I have negative 48x here, and I have negative 66 x here, so I'm going to add 48x to both sides, so that's going to be 18, negative 18x. Okay. Then I move the y's over, so I have 8y here. I'm subtract 72y, so that's going to give me negative 64y. Okay. I add 108. I'm going to add these two together first, and they actually come out to be a nice number. This, and this together, if you put in your calculator, gives you 85, which I'm going to subtract 144 from, and I get negative 59. Okay. As we do that. Okay. Now, what I would suggest for you is to take. You can't do this in if you're like not confident in your answer, which I was checking and I wasn't confident. Right. So what I did is I went to Desmos and I entered my equation. So for any of these, you can always use Desmos, and it's going to work. So you enter in exactly how it looks. Right. And I'm doing it right now. You just can't see it because I'm not using the right software to do that, but I'll put it in. Okay, and here's what it looks like. Okay, on there. Hopefully hopefully you can see that okay. Okay, so I entered it in, right? Don't worry about this. This is me just checking the focus. Okay, I enter the equation in, and I see that graph. And now, if I want to, let me zoom out to make sure you can really see it, because I can't actually see the screen, right? And if I want to make sure that it seems reasonable, right, I'm going to put in my directrix, right? And how about I plot that focus while I'm at it, right? My focus being, I'm sorry, my vertex while I'm at it. Okay, that looks like the vertex, right? I'm going to put the focus in, right? And then when I put that in, oops. So let's move that down. There we go. Okay, that looks very reasonable. If we look at it, that's the vertex. This distance looks equal to that distance, so we can be confident in our answer that it's all said and done. Okay.